So I'm going to do more examples of proofs, and then after I do just a couple examples, we're going to do an in-class assignment and practice again. The proof writing is a skill. Like I said, all the same ingredients go into it. The only thing that's going to differ as we move forward is we have more things that we can put down under the no because we have more information as we go on in the text. For example, now when we have D is the GCD of two integers, we also have now not just the definition, we have the linear combination theorem that we can put down. So in this problem, this is number 14 in section 2, I didn't assign it, but it's very similar to all the other problems. If an integer n is composite, then the integer 2 to the n minus 1 is composite. So the no is that n is composite. That means n is not prime. And what do I know about composite numbers? The only thing I know is that I can expand it into prime numbers. And I didn't do the full expansion like P1. They have in the book P1 times P2 times so forth. I just pulled out and said I could be able to factor out 1 prime. And if this approach doesn't work, then I would go back to the long P1 to the E1, P2 to the E2. And I don't know what page that's on in your book, but they have the expansion into primes written down in formula. But I mean, in its bare minimum, it means that you can factor out a prime. So that's where that's coming from. I'm trying to dissect it out. Why would I do this? Why would I immediately translate the no like this? What's the purpose of doing that? Gives you something to work with. Gives you a nugget to work with, so you have some formula to work with. What am I supposed to show? Well, that's highlighted here. The integer 2 to the n minus 1 is composite. That means I have to show that the same thing I wrote down for the no. But I don't have a p here. Why don't I have a p there? It could be different, right? It doesn't necessarily have to be the same prime. So just to immunize myself on the probability that it might not be the same prime, I just call it a different letter. It may end up being the same prime. I don't know yet.
Excuse me, what did you get? 2 times alpha? Oh, no, I got it.
That's great, answering your own questions. Which one? What was your question again?
2 to the n minus 1. Why does it equal 3 times alpha?
Because I have to. This is what I have to show. I have to show that it's composite. To show it's composite, it means that I have to factor out a prime. Got it? That's the expansion of the show. When I do this on the like this, it probably seems really easy. It doesn't show you the amount of work. I mean, I do this. I think about math every single day, and I've thought about math every single day since 1991. I don't even take summers off. I mean, I really think about math every single day. So you'd hope that after a while something would stick. So keep that in mind when you're watching it and thinking, well, that's easy. I should be able to sit down 5 minutes and do it. A lot of work went into, a lot of experience went into that.
So is that a 14 or 15? It's just the...
I have problems with numbers.
I'm
going to give 14.
The power.
Right, I have to show, that's it.
N minus 1 is a power?
Yes, n minus 1 is a...
Well,
No, it's
a 15th.
n minus 1 is a power, yes.
It's a power.
Yeah, I just wrote it badly.
Okay.
I wrote it badly there too. So I like that someone in the class spends a lot of time experimenting with numbers, because that's the approach I always use. I got to see it with numbers to figure out why this might be true. It really helps for me to see it. Not everybody's like that. I had a colleague I worked with at West Point who could just theoretically shape things, and that's how he thought. Ethan Burkove, he's now at Lafayette. For me, I got to see the numbers and play with the numbers. So I just ran it on Excel. I put the n's in one column, and I put the 2 to the n minus 1s in the next column. And then I looked at where the numbers are composite on the n column, and I just wanted to see what number I get in the 2n minus 1 column to see 2 to the n minus 1 column to see if they matched up. And so I saw, okay, and when the numbers got bigger, so 15 is obvious, that's composite, 63 is obvious, that's composite, 255 is composite, I can see that. But I couldn't really see the 511, so I just checked, and 7 indeed divides it, and 1023 is divisible by 3. So I started messing around. I took my null, which is n is p times s, and I put it in the exponent of 2 to the n minus 1. I wrote that poorly again. And I found out, what can I do with that? Well, I can start factoring. And there's my number at the end. I've got a factor. So I've got something that divides 2 to the n minus 1. So 2 to the n minus 1 cannot be prime. So I wanted to point out here this idea of factoring a difference of something. Everybody teaches calculus. All of you that are going to teach high school will one day teach calculus. So you start thinking about calculus all the time. In the beginning of calculus, when you try to show what the derivative of x squared is, and you do that the long way, you put x plus delta x, and then you subtract. Do you remember doing that a long time ago? Well, if you're teaching, you're going to do that again and again every time you teach it. So in that expansion, you do exactly this right here that you did at the bottom. So I got the idea of expanding from somewhere else. So that's what makes writing proofs so different. You're taking this large toolbox and then stretching out and saying, what can I grab from what I know to solve this, to arrive at those logical steps? Okay, this is a nice proof. Assume that it's composite. Then we can express n as p times s. And actually, I think you're right. I'm doing a completely different problem. I'm showing that 2 to the n minus 1 is composite. So I think it is, yeah, 15.
But you're proving the 14.
Yeah, I wrote it down as 14.
They are switched a little bit there. What do you have to show? What do you know?
Right, I'm proving the statement that I wrote up here. So erase number 14 or 15. I'm proving the statement I wrote up here. So I'm proving that 2 to the n minus 1 is composite. To see this, factor 2 to the n minus 1. And by the way, if you forget these formulas, they're all online. Wikipedia, you can find them. They have the expansion. So I just grabbed it from somewhere. It's not like I remembered. I just got the idea from calculus. Nobody explains. Sometimes you just see that and they don't explain why. In your book, that's a perfect example. Sometimes there's a leap and there's no explanation where that leap came from. So 2 to the s minus 1 is a factor of 2 to the n minus 1. And that's an integer that's bigger than 1. So I've arrived at exactly where I wanted to arrive. I've got something to divide. Once I got some number to divide my original number, it's automatically composite. Since I have a common divisor, then 2 to the n minus 1 is not prime, and hence it's composite.